Hi, welcome to the Linux channel. So whenever I consult about WAN optimization architecture, and especially when I consult about Toffee as a part of paid support, I get certain queries, and especially I get questions regarding the architectural decisions, and especially when it comes to a situation where we need to fit a Toffee data center inside their existing customer premises equipment or something like that. So there will be certain options I generally mention and in that way they can integrate Toffee in whichever way they want. And so I thought let me discuss about some extent of taking such an architectural decision, so that this video will help in case if you are an OEM and looking forward putting Toffee data center into your existing product line, a sort of direction like this will help you. So if you think in a broad perspective, let me just zoom this image. I did this quick image so that it assists you in terms of getting a sort of clear picture. So you can see here, let us assume this is our typical Linux stack. So this is a generic architectural diagram which I discussed in various Linux specific videos, versus this I have done earlier, and for this episode I have little bit extended so that we can get that full big picture. So you have the kernel, which is the software layer, and beneath the kernel you have the real hardware layer, and in between you have the device drivers, and one side you have the networking subsystem, the other side you have storage and other stuff. So here is where in the networking subsystem you have V4, IPv4 stack, V6 stack, and other components. So inside you have the other mundane modules. Let's not go much in depth. So you have this kernel part, and you have the user space part, and you have also something like DPDK. So if you architect WAN opt packet forwarding engine, you can architect whichever way you want. If you want within the Linux networking subsystem, you can put this WAN opt packet forwarding stuff inside this. And if you take as an example the Traffic Squeezer, the earlier one before Toffee, as you guys know, is Traffic Squeezer. It all started with Traffic Squeezer. So the Traffic Squeezer is done as a part of kernel space WAN optimization stack. Initially it was done like a pre-alpha or something in user space, but later the mundane Traffic Squeezer is moved into the kernel space, and it is done as a part of kernel space. So once I forked the Toffee from Traffic Squeezer, the Toffee as it is the same fork of Traffic Squeezer. So obviously the Toffee, as you can read in the documentation or in the home page, and as well as I have put something in the updates why I forked Toffee and other stuff. Here if you go, yeah, I just mentioned few things over here. So if you see here at Toffee, when it started, it's just more or less like a name change. So but it is been kept within the part of the bigger agenda is the Toffee project, because the Toffee project, the name comprises this entire ecosystem which I have discussed in few episodes. It's just not about WAN opt, it's also about its research, it's also about education, it's also about various tools, surrounding tools which I have done, so that we can do something like this with all these components as a part of ecosystem. So that's what Toffee's project literally means. So if you see here, the Toffee is a fork of Traffic Squeezer. So essentially Toffee is going to have the same model. It is nothing but it's an entire WAN opt packet forwarding engine. It's done as a part of Linux kernel's subsystem, within the kernel subsystem. So it is going to exist in the kernel space. So it is going to exist inside here, and this is what is its architecture is all about. And much before the Toffee squeezer also had 3 modes. One, it can exist in v4 stack, and one it can exist in as a part of layer 2 bridging and other stuff. So you have a kind of a split, and you can put in both regions. So let's not go much in depth. So this gives certain advantages, because being in kernel space you get certain advantages, but it also have a lot of other disadvantages, because every time you need to do anything you need to modify the entire kernel. And in case if your CP is having some other kernel, and each time we have to pull this, and then we have to port it to the new kernel, and then we have to make it possible to work in that other third-party kernel. And the same way, in case if you have any other architectural device, hardware platform like MIPS or ARM besides Intel, then again we need to do some porting, and we need to fine-tune, we need to customize, and we need to do all sorts of things. So like I said, having a stack like this within the kernel space has its own advantages and its own limitations, and it has its own challenges, and it again purely depends on a specific architecture and a specific requirement and stuff like that. Although the current traffic path or the packet flow has been pushed into the user space as a part of Toffee data center, still if such a situation arises, still it is sometimes makes sense even to push in the kernel space. So we have any kind of flexibility. End of the day, like I mentioned in the video over here, okay, it is not about so like I mentioned in this video, Riverbed and Silver Peak versus Toffee data center or Toffee. So it's not about you just take one ready to use product and then you just deploy it in your customer's premises or something like that. It's not that. If you are a OEM or you are a product manufacturer, you have that full freedom to do whichever way you want, and as a part of the framework it should have such bigger agenda. It's just not about I am competing with any of the existing players. You should understand it's a huge company backed up with so much stock investors, funding and other stuff. I am just an individual, so I don't care whether which is a better solution for WAN optimization. I care about my research, and I'm more focused about the bigger picture, and it can have any sort of combinations. I don't want to stick with any specific case, and I just want to push the Toffee project agenda with that. So it's much bigger than that. I want to encompass the entire bigger picture. So it's just not about doing in some way and then sticking with that. So this is what I have even discussed in that video as well. So there is no reason to compare, and the same way we are not restricted with any specific architecture. So you have one option is you can have it in the kernel space. The other option, the Toffee data center, if you think about it, it is completely started from scratch. I have done from scratch. It's kernel forward engine, and then within that I took that the Toffee's main core components from the kernel space. I have ported to the user space, and then again it's been rewritten, and then again it has been highly refined. So it's completely different than what it existed before. So if you compare now the Toffee data center with the Toffee or even the older Traffic Squeezer, it's completely different. So I can really bet you after each 6 months, if you see my code, it is going to change left and right. So you will feel this guy have become nuts. So just generally I do lot of changes, and sometimes it's also about optimizing for the hardware. It's also about increasing the performance, and it's also about optimization of the incoming traffic and things like that. Sometimes it's just about reducing the latency and improving the packet processing performance. Sometimes it's all about improving the packet optimization performance. So it's all about reducing the packet size and with what processing overhead. So this is a sort of TikTok cycles even I have, just like the way Intel has. So I have this as a part of my development criteria. So as a part of Toffee data center, it's been done in the user space, and I have my own entire written from scratch packet forwarding engine. So this has certain advantages because it is highly portable, and I have the other option because this is something again I thought before doing this because I was thinking whether is it required to do my own packet forwarding engine. So you have either you can use the kernel's components and you can do it within the kernel space, or you can do something like this. The third other option is you can even use DPDK stack, and with the DPDK stack you can build your Toffee data center within the same as well. So this is also another option. I in fact thought about it before doing it. I thought option 3, so that I can have the ready to use DPDK stack as a part of packet forwarding engine, and within the same I thought of incorporating the WAN opt solution, and then I can support the Toffee WAN optimization within the same. I have also this option. There is one advantage is this packet forwarding engine may have lesser latency, the raw engine alone. So it may have lesser latency than something like this. The reason is, as if you check DPDK stack, it directly gets the packets directly from device driver. So let me just use some arrow or something. So it directly uses, or it directly connects from here to here. So it directly pulls the packets right out the device driver layer, or else maybe the net core layer. So it directly pulls the packets from there and then it processes the same. So this improves the efficiency versus the way I am doing currently is through here to here. So in this way maybe its efficiency is much better than my packet forwarding engine. But having said that, DPDK has its own challenges. It's like using some kind of cleaver knife to do some minor surgery. So it's a sort of wrong tool for that specific thing. So it has its advantages. DPDK has its advantages, but again you have this issue like it's done for Intel, it's done by Intel. So in case if you use it next in future for ARM or other architectures, we need to see how far it is compatible, how far it is portable and stuff like that. So this is something I don't want to get into other third-party stuff, and I don't want to have any sort of issue. So I have all these options, and this is also something many people are confused. Why not I get one make install script or something like that? See, one should understand this is not something I have done like your typical open source project. You have some dumb etc config file, you just go and do some command line configuration and then you get something, and then again you do something manual here and there. I don't want that. I want an entire stuff as a part of WAN optimization solution. I want that entire stuff as a part of offering. So it has its own GUI components, it has its own CLI components, it has its own the core packet forwarding engine, and it has all sorts of extensions, so that it is more like a framework rather than your typical yet another make install open source project. So this is the reason I don't have all this stuff. And in fact, if you see how far it is different from other open source projects is, I don't have any configuration file in any etc folder. So instead I have this configuration parameters in MySQL database. So this itself is completely out of norm. So this itself breaks the rule of any open source project. So there itself it is completely different, and so it differs a lot than your regular open source project. It is open source, but having said that, it has different agenda. It's not like your typical average open source project where you just take it and then do some make, compile and stuff like that. I'm really customized this for OEMs and large vendors where they can use this framework in whichever way they want. As I said, I have all these options. Even now, if someone tells, okay, I need on top of DPDK stack, I don't need it, I don't need your custom packet forward engine, then I can just pull certain modules and I can completely redo on top of DPDK. But having said so, as a default Toffee data center offering, I don't want to put inside DPDK and make some kind of vendor lock-in or some kind of platform dependency stuff. So this is the reason I have done my own packet forwarding engine, and within the same I have done the Toffee data center WAN opt modules. So with that I have that full flexibility. I can change whichever way I want, and since it's my own forwarding engine, I can do any sort of changes, and this also works more like a sort of microkernel sort of architecture. So this again gives a lot of flexibility. It's just not your typical average network stack. It's just not that. So it has a lot of things involved. All these things work perfectly in sync with each other, and it's been highly modularized so that any module can be replaced, any sequence can be changed, any module can be debugged, any module can be tweaked around, any module can be offloaded in case if you want compression on a hardware, you don't want it in the software, it can be offloaded. So several things are possible with that. So these are certain things I discuss as a part of paid consultation, but again I thought this is something interesting to share so that this gives as well that big picture. It is not something your typical average open source project where you just take some few .c files, you have some make script, you just to do make, compile, make, install, and then it is done. And then you have some etc file and you go and that etc file you change some parameters here and there and then done. It's not that. So it's completely different agenda. It's not that, and this sort of approach gives that customizability, and it gives that flexibility so that if you want it in the kernel space, it can be moved for certain applications. If you want it in the user space, it can be moved for certain applications, and if you want it within some third-party packet forwarding stack, for example like DPDK, you can even push into DPDK stack and then you can incorporate a WAN opt in the same. So this is the sort of the reason first you need to think about using Toffee data center, and it is not something where you sit and compare with some ready to use commercial applications. Their agenda is completely different. Mine is all about I have recipes and I have ingredients to cook, and you just order the dish. I can mix and match, and I can vary the cooking time, and I can make whatever the dish you want. So this is what it is. I am in restaurant business sort of, versus you are talking about, if you think about commercial products, you are talking about ready to eat factory produced food. So there's a lot of difference between that and this. So all I'm kind of giving is a sort of that bigger picture in this episode, so that you have this sort of flexibility. And again, it as I said, each case is different. Sometimes you have a very tiny customer premise equipment, you just need it quickly, some extent WAN opt. In that you can compromise some amount of optimization, you can do the same. Sometimes you need it for some kind of mobile device, and in that case you don't need some full-fledged WAN optimization, you can do the same. Sometimes you need it only single direction, you don't need bidirectional optimization, you need to just optimize whatever you are getting from the remote end, you don't need to optimize whatever you are sending. Then again you can do the same. So you can do whichever way you want to customize. Sometimes you want to send all these packets in some kind of UDP tunnel, and sometimes you want to send as a part of TCP tunnel, or sometimes you want to use some third party IP protocol, you can do the same with Toffee data center framework. So this is the sort of big picture you can fit in whichever way we want, and this is the sort of reason I have such a project with a large agenda. It's just not your typical WAN project. So this video is really again for OEMs and product manufacturers, and if you are a network admin, I'm sorry to say that, as I say in many episodes, I'm only supporting Toffee data center as a part of paid support, although it is open source. Of course you can go through the source, but I'm only supporting as part of paid support. So hope you guys loved watching this video. In case if you have any questions, be in touch via mail. And beyond a certain criteria, of course, I'm going to say that whatever you ask, even that I'm going to support as a part of paid support. But there are, of course, certain things I would like to share if it is fine as a part of general inquiry. So thanks a lot for joining me. Stay tuned. Have a nice day. Bye-bye.